So here is another example of oblique collisions. Should change to red here. Two smooth spheres of mass 4m and 7m kilograms collide obliquely along a shared horizontal axis. The spheres travel at the same speed towards each other in separate horizontal directions. I don't know why my pen keeps doing that. And both are an angle theta to the horizontal. Show that the heavier particle cannot travel vertically as a result of the collision. So, when you're ready, go ahead and try this problem, and come back for the solution if necessary. So here's the solution. We have our spheres colliding, and this should actually be minus u cos alpha. It's minus u cos alpha here. So we have u cos theta plus u sine theta of the first one, and the same thing here, but there should be a negative sign in front of here. So I'll just plop that in now. So that should be minus u cos alpha, or u cos theta. So starting with the conservation of linear momentum, we get that 4m times u cos alpha plus 7m times minus u cos alpha is mv1 plus mv2. Now, because we're dealing with the component of the velocity that's actually changing, if we wanted to travel vertically, the horizontal component of the velocity must be 0. So in that case, v2 is 0. So we get minus 3u cos theta equals v1. And that's our first equation. Now, with Newton's law of restitution, we get v1 minus v2, which we've determined as 0, is minus e times u cos theta minus negative u cos theta. So v1 is minus 2 eu cos theta. So we have a relationship for v1. So minus 3u cos theta is minus 2 eu cos theta. So if we divide by minus 2, we get e equals 3 halves. Now, of course, this can't happen because e has to be between 0 and 1. So because the coefficient of restitution is outside of the valid range, we can conclude that a collision like this is impossible.